All right, well, good morning, everyone. Today, here's what we're going to be talking about. We're going to talk about what are called dividing radicals. So here's our objective. I can divide radical expressions and then simplify. Keep in mind that that simplifying part is what you need to kind of be careful with. So here are kind of some hints and step-by-steps for dividing radicals. First step, simplify the fraction if possible. Now, that's not always going to happen, but when you can simplify, it makes your life a whole heck of a lot easier. Second step is then simplify the radicals if possible. So in other words, if you've got two radicals, one numerator, one denominator, that you can go ahead and simplify, go ahead and do it, because then boom, you're done. Now, sometimes you won't be able to do either of those, and when that happens, you have to do what's called rationalizing the denominator. So, with rationalizing the denominator, which is the first thing that we're going to kind of talk about here, and I'll kind of write that down here. So we're going to talk about rationalizing the denominator. Here is what you will need to do if you want to rationalize the denominator or eliminate the radical from your denominator. You have to, in step one, be sure that you multiply if one term, so if there's a single term, rather than, 2, 3, 4 terms. If there's just a single term, you multiply by the same radical as what you have in the denominator. Now, where that gets a little tricky is that if there are two terms, you have to multiply by the conjugate of the denominator. Keep in mind, conjugate we've already kind of talked about. We talked about that before when we talked about complex numbers. And what we said there was whenever you want to multiply by the conjugate of a denominator, the conjugate is basically where you just switch the sign in the middle and then multiply. All right, so tell you what, let's take a look at a few examples here today, and then you'll have some time to practice for the rest of class. So, very first example I want us to look at here is example number 1. In example number 1, where you've got the square root of 125 divided by the square root of 5. If we can simplify, we need to go ahead and simplify, which means that if you can divide those two numbers, go ahead and divide. You just have to remember to keep it under the radical. In other words, if you take 125 and divide by 5, you get the number 25. But we haven't done anything with our square roots yet, so you have to leave that as a square root. But hey, here's what's kind of nice. Square root of 25, we know what that is. That's just the number 5. And just like that, you're done. All right, so take a look with me at example number 2, which will be very, very similar. The only difference is that you've got the division underneath the radical bar already. So what you can do here is you can take square root of 90 over 5 and simplify that to be the square root of, when you take 90 divided by 5, you get 18. So we're going to try to simplify square root of 18. At this point, if you want to practice, this would be a good chance to pause the video and see how you're doing with simplifying. All right, here we go. Here are my two factors that I found. Square root of 9 and square root of 2, because 9 was the biggest perfect square I could divide 18 by. Square root of 9 simplifies to be 3. Square root of 2 is irrational. You leave it alone. There would be your final answer. Now, those tricks are kind of nice, and they're good to use when they work. Here's the problem, is they don't always work. Like if you take a look at number 3, for example. In number 3, where you've got 2 square root of 11 divided by 4 square root of 5. Here your square roots can't simplify. Square root of 11 divided by square root of 5, it's not going to be a whole number. We can't do anything with it. So instead, here's some other stuff we can do. There's actually something you can simplify right away. Take a look and see if you can find it. So, hopefully you saw both 2 and 4 are divisible by the same number. They're both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Now, that'll help us a little bit. That at least gets us to this step, where you have 1 multiplied by the square root of 11. You can just drop the 1, is the same as just square root of 11. And then 2 square root of 5, you leave alone. Now, in this case, there's nothing else we can do to simplify. We can't divide, and we can't just take square root of 11 or just the square root of 5. So here's where you have to go to kind of your last option, which is to rationalize. So if we're going to rationalize, and in this case we only had one term. So if one term it says multiply by the same radical as in the denominator. In other words, we want to use the exact same radical as what we see in our denominator. All right, well, let's take a look here. In my denominator, I've got a square root of 5. So if I'm going to simplify, I need to multiply by that exact same square root and multiply by the square root of 5 over the square root of 5. Now, when we go to simplify, keep in mind here's where you're going to have to use some other skills. You're going to have to use some multiplying too. Square root of 11 times square root of 5, you get square root of 55. And then in denominator, the 2 is kind of left alone. Square root of 5 multiplied by the square root of 5 should just give you the number 5. If you still need the in-between step and say square root of 25 and then simplify, obviously that's an option, but I hope we're getting to a point where we don't really need that step anymore. Now to simplify, really only one more thing you can do at this point. Square root of 55 actually won't simplify at all, so the only thing left to do is take your denominator where you see 2 multiplied by 5 and rewrite that as the number 10 instead. Alright, so at this point, what I want you to do is take a look at number 4 real quick here. Number 4 is actually set up very, very similar to number 3. The one difference being you really don't have anything to simplify right off the bat. With 2 and 3 over 3 radical 6, there's not even any reducing of the numbers that you can do. But it'll work very, very similar to number 3, especially our second steps there. So what I want you to do is try number 4 on your own. So pause the video at this point. Let's check and see how you're doing. Alright, so hopefully you saw in this one as well, there's really nothing you can do other than to kind of go back to rationalizing, where you multiply by the same square root as what you see in your denominator. For this one would just be the square root of 6 over square root of 6. Now, when you multiply, in your numerator, 2 multiplied by the square root of 6, you just get a 2 square root of 6. In denominator now, the 3 again would be left alone. Square root of 6 multiplied by square root of 6, you get just the number 6. And then as we simplify here, just like before, we multiply our two numbers in our denominator. 3 multiplied by 6, you get 18. Now there is something you can simplify. If you look at your numbers in front, 2 and 18 are both divisible by 2. 2 divided by 2 is a 1. 18 divided by 2 would be 9. And so for your final answer here, 1 multiplied by the square root of 6, or just square root of 6, divided by, in our denominator, just the number 9. And there would be your final answer. Alright, 2 more, and we're going to call it a day. Now these last 2 are going to take a little bit of time, so follow along closely. If you need to go back in the video and rewatch some steps, just make sure that you're getting these all the way down. On number 5, where you've got 4 divided by 3 minus radical 7, some things to kind of point out here is that you do not have anything that'll simplify. You can't take 4 divided by 3, can't take 4 divided by square root of 7. This time you actually have 2 terms though. So you've got 2 terms in your denominator. What that means for us is that now we're going to have to do something a little different. We have to go up here and it says if there are 2 terms. Then we need to multiply by the conjugate of the denominator. Meaning the conjugate is where you will switch the sign in the middle and then multiply by that in both numerator and denominator. So let's see how this first one will work, and then we'll have one for you to try on your own. So, on number 5, here's how it's going to work, is that you basically will just copy down your denominator same as it's written. The one difference being instead of 3 minus the square root of 7, you write 3 plus the square root of 7 instead. Now, we're going to be multiplying by that in both numerator and denominator. Here's one thing I do want to point out. Please, please, please be sure to put the denominator for your original expression in parentheses. That way you remember to distribute. So, we'll take this piece by piece. In numerator, 4 multiplied by 3 is 12, and then 4 multiplied by the square root of 7, you get a positive 4 square root of 7. Now, denominator is where things are going to get a little bit more tricky. 3 multiplied by 3 gives you 9. 3 multiplied by square root of 7, you get a plus 3 square root of 7. Then, second term here, negative square root of 7 multiplied by 3, you get a minus 3 square root of 7. And then the last one here, this is the one I want you to watch carefully. Negative square root of 7 multiplied by positive square root of 7. First thing, negative multiplied by a positive, it's going to be a negative number. And then square root of 7 multiplied by the square root of 7 should just be a 7. Now, here's going to be some kind of nice stuff that works out for us. It is similar to when we worked with complex numbers. When you multiplied by the conjugate, your middle 2 terms in your denominator added to be 0. Same idea works here, is that you can add both of those to be 0. When you do, here's what you're left with. In your numerator, you still have a 12 plus 4 square root of 7 divided by, now in denominator, you've got 9 minus 7 is a positive 2. All right, one more step to go here. Only thing you have left to do at this point is look to see if you can simplify these three numbers, which are your coefficients. This time you actually can. They're all divisible by 2. 12 divided by 2 is 6. 4 divided by 2 is 2. 2 divided by 2 is 1, and so it divides out. So your final answer here, you would have had a 6 left in your numerator, plus a 2 radical 7. If you wanted to write it over 1, you could, but at this point, you would be done. All right, one more example to look at, and we'll call it a day here. In fact, number 6 works very, very similar to number 5. The only difference being you've got a little bit more of simplifying to do in your numerator first. Now, what I want you to do is go ahead and try it on your own if you feel comfortable with it, and that way you can check your answers. We'll go over it in just a second here. All right, so what I'm hoping you notice is that just like before, you're going to have a denominator that won't simplify and where you have two expressions, two terms. So, with that being said, we are going to multiply by 1 minus the square root of 2, which would be the conjugate. So, when you multiply by 1 minus the square root of 2, make sure everything from your original expression gets put in parentheses because there's going to be lots and lots of distributing we have to do. Let's start with our numerator. 13 multiplied by 1, you get 13. 13 multiplied by a negative square root of 2, you get a minus 13 square root of 2. Then negative square root of 2 multiplied by 1, you get a minus square root of 2. And then negative square root of 2 multiplied by negative square root of 2. Negative multiplied by negative gives you a positive. Square root of 2 multiplied by the square root of 2, you just get the number 2. All right, denominator time. So 1 multiplied by 1, you get 1. 1 multiplied by the negative square root of 2 is a minus square root of 2. Positive square root of 2 multiplied by 1, you get a positive square root of 2. And then positive square root of 2 multiplied by negative square root of 2, you get a minus 2. At this point, simplifying, let's go. So, first things first, if we did things right, our two middle terms in the denominator should add to be 0, and they do. Now, a couple of other things we can do here is that in our numerator, we've got some terms we can combine together. 13 and positive 2 give you a positive 15. In the middle here, negative 13 square root of 2 and negative square root of 2, hey, that's what we worked on yesterday. There's adding and subtracting. So negative 13, take away one more, you get a minus 14 square root of 2. And then in the denominator now, 1 minus a positive 2, you get a negative 1 there. Now, to simplify, here's the only thing you really have left that you can do is that now, with dividing by negative 1, basically what that does is that it just switches your signs for both terms in your numerator. In other words, your positive 15 here becomes a negative 15. Your negative 14 here becomes a positive 14. Square root of 2 stays the same. Here would be your final answer. All right, a couple things to talk about real quick here. At this point, we are basically done with notes for today. Those are the only things we were going to go over on Wednesday or Thursday when I'll see you again. We will be taking a quiz and then working on more properties of exponents. So with that quiz, what that means is that there won't be a homework quiz. You will just show up, we'll take a regular quiz. I am still thinking about making it an open note quiz. We'll have to see how the sub kind of gives you a rating and see how you did, how well you behaved, but I'm thinking that open note quiz is a very likely outcome. Now, that being said, there is still some homework you need to practice. That homework is worksheet, dividing radicals. I've already got it posted on Schoology for you, so you should be able to hop on there and get to work. Keep in mind, the answer key is posted there as well, so check your answers. Check your answers. I will collect that on block day when I see you again. Keep in mind, quiz coming up. Also, make sure if you're missing anything, I have updated grades, so if you are missing anything, especially if you're missing like your review for last unit, or you're missing the Unit 7 quiz that you're supposed to be corrected, and there's lots of people that are missing that. Or if you're missing anything from graphing rationals, whether it's the quiz and you've made an arrangement with me to take it, or just even the homework that was due that is being taken as points, make sure you're getting that turned in. Have a great rest of your Tuesday, guys. I will see you on block day.